maybe remind yourself how to do stuff if you can take the 5 seconds to do that. I don't know if you'd ever do it or not. We'll see. But I'll start a YouTube channel for Mr. Chaft. I don't know. We'll see if you guys will actually do it or not. Okay. So no solutions or infinitely many solutions. All right.
Do you have one or you don't?
I have one.
What's it called?
Mr. Taft Math. All right. So, okay. So no solutions or infinitely many solutions. These are two situations that pop up, and it's usually really complicated, or not really complicated. It's usually really difficult for Algebra 1 students to understand the difference between the two. Usually it's really easy for Algebra 1 students to understand when these pop up. It's just really difficult for Algebra 1 students to understand when it's no solutions or when it's infinitely many solutions. Now let me show you when these pop up. So, a situation that might happen, and let me show you an example of a multi-step equation. And this just happens to be one of the things on the test that it seemed like a lot of people needed to review. There were two things on the test that we needed to review. One of them was multi-step equations, and the other one was the order of operations. So on the test, and not everybody got this wrong, but question 1 and 2, especially question 2, it seemed like almost everybody got question 2 wrong. And then the last 4 on the front page, those were not great for everybody. And those were the multi-step equations. So I just wanted to spend some time reviewing those topics. Anyway, so no solutions and infinitely many solutions. An example of when this might show up. Let's do 3 times in parentheses x plus 4, close parentheses, and then we'll do plus 5 is equal to, and then the other side we'll do 3x plus 8. All right. So now using the rules that I taught you guys mere weeks ago on how to solve multi-step equations, the first thing that you need to do is what, Elijah? Right. Right, and what is 3 times x? Cool. And then what's 3 times 4? Plus 12. Perfect. And then I just drop everything else down. So plus 5 equal to, and then I've got 3x plus 8. All right. Cool. So distribute was the first step I gave you guys a few weeks ago when we started covering these multi-step equations. Zach, do you remember what the next step was?
To combine like terms.
Combine like terms. Perfect. On the left-hand side, are there any like terms I can combine?
Yeah.
Okay, so what are the like terms on the left-hand side, Zach?
12 and 5.
12 and 5. If I combine plus 12 and plus 5, what do they make?
Plus 17.
All right, thank you, Zach, in stereo. So that makes plus 17. Still got a 3x here. I've got equal to, and then I've got 3x, and then plus 8. Everything else just drops down because I didn't mess with it. All right, Michael, also known as Zach2. After I distributed, and after I combined like terms, what was the next step? Variables and constants to, so variables to one side, constants to the other. So, Michael, what side do you want the variables on, and what side do you want the constants on? Variables on the left. That means constants have to go to the right. Which one do you want to move first, the variables or the constants? Okay, so that means I need to move this plus 17 to the right-hand side. How do I move plus 17, Michael? So I'm going to minus 17 here, minus 17 here. So Michael, what does plus 17 minus 17 turn into? Okay, it turns into nothing. And then on the right-hand side, Michael, what does plus 18 minus 17 turn into? Negative 9. Drop everything else down. So 3x just comes down, equal sign comes down, and then 3x comes down. All right, cool. Juju, how do I move this 3x to the other side? So I'm going to minus 3x, not just 3, but 3x, right? So minus 3x minus 3x. So what happens to 3x minus 3x, Juju? It doesn't turn into x. Yeah, it goes away completely. And then over here, what is 3x minus 3x? 0. Okay, cool. So on the left-hand side, I've got nothing left. And Juju, what number represents nothing? Not 1. 0. 0 represents nothing. 1 represents 1. And then I drop down the negative 9. Okay, so now there's no more x left. So here's part for your notes. If there's no more x, so no x or y or whatever variable left, so no x left, you're either going to have either no solutions or infinitely many solutions. So if the x falls out entirely, there's no more variable left in your equation once you get to this point, then it's either going to be no solutions or infinitely many solutions. All right? Now here's how you tell which is which. In this case, are these two equal to each other? Okay. So if not equal, then no solutions. And what that means is there's no number I can pick at this first statement or anywhere along the line. The second line, the third line, there's nowhere along the line. There's no number I can put in for x up here that's going to make the left-hand side balance with the right-hand side. And the reason why that's true is there's nothing I can do to make 0 be equal to negative 9. There's no number I can pick for x to make 0 be equal to negative 9. Kinda, sorta. There's no x value that's going to make the left-hand side be equal to the right-hand side. So there's no solutions. There's two other ways that you can write this, because I know you guys don't like writing out words because work. The other two ways you can do that is you can draw a 0 with this diagonal line through it. And in math, that's something called the empty set. Which, I mean, you don't have to necessarily know what that is. In the military, that's just how they draw their zeros. But in math, the 0 with the line through it is called the empty set. And then the other thing you could do is write the word null, N-U-L-L. The word null in math means no solutions. So you could either write no solutions, or I'd even be okay if you abbreviated it NS. You could write 0 with a slash through it, or you could write the word null. Any of those would be fine. Now this is if these two things are not equal. Now let's take a look at another example here, okay? So Nathan, you're going to help me out first here, all right? Yep, you're going to help me out first, all right? Okay. So this example we're going to do, let's say, 2 times in parentheses. Let's do x plus 4, close parentheses, plus 3x plus 5 is equal to 5 times in parentheses x plus 1, close parentheses, plus 8. Oh my, look how glorious that problem is. So many steps. It's wonderful. Such math. It's wonderful. It is? It is. So Nathan, you're going to help me out first, all right, bud? Okay. So what do we do first, man?
Multiply the parentheses.
Okay. So yeah, you multiply the parentheses, fine. Don't jump down his throat. So what does that look like on the left-hand side?
2x plus 8.
Great. And then I'm going to drop down the plus 3x plus 5. Going to drop down the equal to. Now on the right-hand side, what does it look like?
5x
Mm-hmm.
plus 5.
Great. And I'm going to drop down the plus 8. Awesome. Thank you. All right. So I distributed first, and that's my first step. Now, test. After I distribute, what's my next step? Perfect. Tess, I'm going to have you take just the left-hand side. What are the like terms on the left-hand side?
2x and 3x and then 85.
Great. 2x plus 3x, what do those make together?
5.
Great. So I've got 5x, and then plus 8 plus 5, what does that make? So I'm going to do plus 13. I'm going to drop down my equal sign. Now on the right-hand side here, Cade, what like terms do I have on the right-hand side? 8 and 5. So plus 5 and plus 8, what do they make?
13.
So plus 13. Going to drop down 5x. All right, so I distributed. I combined like terms. Bless you. Bless you. Now I need to get constants to one side, variables to the other. All right, so Emily, what side do you want the constants on? What side do you want the variables on? Variables on the left, constants on the right. So which one do you want to move first, constants or variables? Great. So that means we need to move this plus 13 from the left to the right. How do we move plus 13? So we're going to minus 13. We're going to do the same thing to the right-hand side. So this goes away. And what is plus 13 minus 13? Great, that goes away too then. So I'm left with 5x equal to 5x. This is a little freaky. So then one more step here. Mr. Comble, what do I need to do to both sides?
Divide by 5.
No, no, no. Not divide yet. How do I move 5x to the other side?
Subtract.
So I'm going to minus 5x. Michaela was right. Or if that wasn't Michaela, it was Casper.
It was Casper.
Okay.
It wasn't Michaela.
So I'm going to, she's taking credit for it.
Yep.
So I'm going to minus 5x from here. That goes away. What do I put when everything goes away? What number goes there? Okay. When I minus 5x from here, let me move my camera down. When I minus 5x from here, everything goes away. And I put a 0 there too. Now, right, in this case, they are equal. Okay? So x has gone away entirely. So no x is left, just like up here. There's still no x. So it's either no solution or it's infinitely many solutions. But in this case, they are equal. So if they are equal, then infinitely many solutions. Infinitely many solutions. And holy cow, look, that's 3 words, and 2 of those words are super long. Infinitely, that's 4 syllables. Solutions, that's 3 syllables. Holy cow. So if you don't want to have to write all of that, there's a couple different ways you can abbreviate it. The first way you can abbreviate it is IMS for infinitely many solutions. And the second way you can abbreviate it is the infinity symbol, which is this kind of sideways 8. So no matter what number, what this means is no matter what number I put in here for x up here at the very beginning, I could put 5 in here and it's always going to be true. And the reason it's always going to be true is because 0 is always going to be equal to 0. So if I put 5 in here at the very beginning, 5 plus 4 is 9, 9 times 2 is 18, 18 plus 15 is 33, 33 plus 5 is 38. Over here, 5 plus 1 is 6, 6 times 5 is 30, 30 plus 8 is 38. It balanced. If I put a different number in, it would balance too. No matter what number I put in here, if I put a billion in here, it would balance on both sides. Great. So what's a billion plus 4?
2,000,000,004.
Okay, times 2,
2,000,000,008.
plus 3 billion,
5,000,000,000.
plus 5.
5,000,000,013.
Okay, 5,000,013,000. All right, you're going to hold on to that number in your head, right? 5,000,013,000. All right, over here, I've got a billion plus 1, which is a billion and 1, times 5,
5,000,005.
plus 8.
5,000,013.
So 5 was an answer, but so was a billion. So no matter what number I put in, if I put negative a billion in here, if I put
We're good.
No, we're good.
That's
No.
not
Skip that.
negative.
no matter what number I put in here, it's always going to balance on both sides. So no matter what number I put in here, it balances on both sides. 5, a billion, 5 billion, 75 billion and 1, 75 billion 36, 75 billion 37,
0.
75 billion 37.7, 0. It's going to balance on both sides no matter what. And so it's infinitely many solutions. That's why we use this little infinity symbol here. However, this one up here there's no number that you can come up with that's going to make both of these sides balance, because there's no number that's going to make 0 be equal to negative 9. There's nothing you can do to make 0 the same as negative 9. Kind of, sort of? Yes, no, maybe so? All right. So that's the lesson for today.